Hi, Sierra. I'm going to go through just a really quick example to show you how to calculate the values for the regression. Okay, so let's start with a table of values. We need some data. We need X and Y. And I'll just go 1, 2, 3, 4, 5. And then I'll just go, let's do 2, 4, 6, 8, 10 here. Okay. So we need to find a few things before we can jump into the formula. The first thing we need is our X bar and our Y bar values, and those are the mean values. In the case of X, if we add all those together, we get a sum of 15, and there are 5 numbers, so 15 divided by 5 is 3. And here we're going to get a sum of 30, and there are 5 numbers. So our mean value is 6 here. Okay. So the next thing we need is these values over here. And so the ones on the bottom, those are your standard deviations for X and Y. The one on the top is your covariance for X and Y. And so let's set up a chart down here where I'm going to have my, let me see how to do this here. If I have my X values, and then my X bar, and then my X minus X bar, and then I want my Y value, my Y bar, and my Y minus Y bar. Move this out of the way a little bit there. Oh, that got stuck together. Okay. All right. And so if I write my numbers 1, 2, 3, 4, and 5, and my X bar is 3, 3, 3, 3, 3, then the difference between those numbers is negative 2, negative 1, 0, 1, and 2. And if I do the same thing for my Y values, I'm going to write 2, 4, 6, 8, 10 in the chart at the top here. My Y mean is 6, 6, 6, 6, 6. So when I subtract those, I get negative 4, negative 2, 0, 2, and 4. Okay, so that's where the covariance is going to come from. What we're going to do is look just at these numbers and these numbers. And this formula says we're going to multiply them together, and we're going to add them up at the end, and that's how we get our SXY, the covariance. So what I'm going to do first of all is multiply them together. Okay, so I'll just put 2 brackets to indicate I'm multiplying here. I'm going to get 8, 2, 0, 2, 8, and the sum of those is 20. And so that's my covariance for X and Y. My standard deviation for X is just going to be the sum of these guys, and so that's going to be 0, right? Is it 3 plus? Oh, no, I need to square them all first to get my standard deviation. Okay. I'm going to change colors and squeeze that in right beside. So I'm going to get, if I square this, I'm going to get 4, 1, 0, 1, 4. And if I square this, I'm going to get 16, 4, 0, 4, 16. Okay? So my standard deviation for X and my standard deviation for Y come from these values. What happens is I'm going to add them up. So in the case of the X's, I've got a sum of 10. Okay, so sum equals 10. And in the case of the Y's, I've got a sum of 40. And so SX, the standard deviation of X, is the square root of 10 over n minus 1, so that's 4 minus, 5 minus 1 is 4, and so that's the square root of 2.5, and that's 1.58. I know that because I worked it out earlier, okay? Here for sy is the square root of 40 over 4, so that's the square root of 10, and that's approximately 3.1, I think. So I've got those values, I've got my covariance, and I'm ready to jump into the formula that we were looking at and fill all those numbers in. Okay, so we have Sx, we have Sy. Let's go back here to where we took the sum of all of these guys. And what we need to do to get Sxy, the covariance, is to take the 20 and divide it by the 4, and that's going to give us a value of 5. Okay, so now to calculate our R value, just to finish off here, let me move this stuff up. Oh man, iPad is not playing along today. So R is going to be your covariance, which was 5, over your Sx times your Sy, your standard deviations. And so let me just do a quick calculation on that. Okay, so I did calculation and I realized that we needed more decimal places, so I went back and put some more in, and I don't think I've put enough in because the R value can't be bigger than 1. And in this case, I set the numbers up so that the R value is supposed to be exactly 1. So if I had more decimal places, I'm going to get this number closer to 5. And 5 over 5 is equal to 1. And that's how we calculate R. Okay? So once we've got that, it's a building block. R gives us B, B gives us A, then we have our equation. So I'm going to go through now and explain the other slides in terms of this R value of 1. Okay, and so here we've got the correlation coefficient. We call it Pearson's R sometimes. And this is just reiterating what the first slide said. Okay, so this is nothing new. We've already worked through both of these equations. This is sort of the shortcut equation right here. If you set it up in the chart, it'll always be really easy to follow, okay? All right, now that we've got our R value, we're able to calculate B, which is the slope for our regression equation. A regression equation is just the equation of the straight line that goes through all of the points on your scatter plot. And so here, because we know our R is equal to 1, our Sy was the square root of 10, and our Sx was the square root of, I'm trying to think what it was. I think it was 2.5, wasn't it? Okay. And so if I multiply that through, then I'm going to get B, which is the slope. And I need that for the formula down here in terms of getting the y-intercept. And that's what B naught is. That's what B with the little sub-zero is, okay? So that's your initial value or your y-intercept. So once I've calculated B here, I'm going to be able to jump all the way down to the bottom, and I'm going to be able to calculate B naught, the intercept. I can put in my mean value of y and my mean value of x, and it was 3 and 6, right? So I had 6 for the y, and then minus my B value, my slope, times 3, which was x bar, the mean value of B. Okay, so back here when I was calculating B, I think B comes out to 4. And so here when I want my final answer for the intercept of my equation, I'm going to have 6 minus 4 times 3, and that's 6 minus 12, so that's negative 6. So when it comes to writing the regression equation is just y equals mx plus b, like it was in high school, y equals mx plus b. But in statistics, we replace the m with the b1, and then we replace the b with the b naught. sometimes you'll also see an A in the equation, okay? And so here we're just going to write y hat, because it's the predicted value of y, not the exact value, so we put a little hat on it. And then we're going to have 4x minus 6. And sometimes, again, in statistics, I don't know why they will write that backwards. And they'll put the intercept first, and then the slope and the x value. And so you'll see it both ways. Okay, so here they're just explaining what everything is in your regression formula, and we just talked about that a minute ago. So we've got y hat equals the intercept, b naught, plus the slope times x bar. And then why did they write it like that? Ooh. Interesting. Okay. Sorry. Okay. So no, this is not the regression equation. Okay. What they're finding here is they're putting in x bar, not x. And that's going to give us a value that comes out to y bar, because we're looking at the average of the x's here. And so the value that we're going to get out is the average of the y's, because y is a function of x in our equation. And so for individual values, we have b naught plus b1 times x, right? What they're saying here is that if we replace the x with x bar, the mean value of the x's, then what we're going to get out instead of y bar is y mean. It's going to give us the mean value of y, okay? So you can go from this box to this answer, and you don't need the in-between. It's just showing you why that is. So just keep that part out. And then if you were being asked to calculate y bar from the regression equation with the x value, the mean x value in there, then that's how you would do it. So I'm assuming you're going to be able to bring a formula sheet into your midterm, and so you should include that with an example of how to work that one out as well.